Okay, so we're at the very tail end of the semester. I think we have today's lecture and then lecture next week. Or else we'll right into Thanksgiving. I think we have one lecture next week on Tuesday, if I'm not mistaken. I don't believe we're allowed to have lectures on Thursday. I think, correct me if I'm wrong, I think lectures end December 1st, which is a Friday, but I think the last day of class, according to the UNO calendar, is on Wednesday. So if that's the case, we have today's lecture and then we'll have the next lecture. So on today's lecture, I really want to go ahead and complete out the final traces. So I had just released a video previously showing how to get through traces 15, 16, and 17. Of that video, obviously, trace 15 is the longest because the other two traces are contingent on the prior 15 traces. As long as you've implemented everything correctly for the prior traces, you should be able to go ahead and complete 16 and 17. So with that said, the last bit of our shell implementation that we'll have to do is going to really deal with redirects. And so I think this is kind of also a critical section to kind of examine, because it's going to show us how we can manage files at the system level in terms of being able to open, close, and write to them and whatnot. So we'll take a look at that. And I also reopened up all the due dates into AutoLab and gave them a deadline of December 1st, so that you'll be able to use the content from these lectures to supplement that. Okay, with that said, I want to move on to trace 18, and then we'll do a follow-up. Once we kind of cover this, then we'll kind of piece everything together and talk about how we're going to sum up the results of this shell. So if we left off on trace 17, and let's confirm that that is in fact the case. So I'm going to jump over to my shell lab, going to open up a terminal. And let's see here, the last, so let me make our test 17. This is where I'm claiming we last left off. So our reference test shows we get that output, and then our test shows that we will get this output, which looks the same to me. I mean, minus the PIDs. And again, just to confirm, we can do a summation to make sure we get points from trace 1 all the way to trace 17. But while I let this run in the background, let's go ahead and look at what trace 18 is going to go ahead and request, with the assumption that we're going to get points for trace 1 through 17. Okay, so if we go and just inspect the contents of trace 18 that has all the directives to our test harness, we can see that this particular trace revolves around attempting to redirect an output to a file. So we can see, obviously, the header comments always allow us an idea of what this trace is trying to do, and then we can kind of pick through line by line what's happening here. So we can see on this first command, we're invoking that the ls application to go ahead and list the contents of the specified files and redirect the output to this file here. So traditionally, we've been printing out the contents of our application to standard out, which then displays to our monitor into whatever our display is. So the symbol here, the greater than symbol, when put into a shell command as part of your set of arguments, can redirect from your standard out to a particular file. I'm sure you've already seen this before many times. Now, our shell should also offer that implementation. Like, that's an expectation that whether you're using bash or C shell or whatever, right? Whatever shell you're using, there's an expectation that you can do redirects. Okay, so the first line here is clearly we're trying to redirect from our standard out to this file, test that out. Then the next command is we're going to call on the cat application inside of our binary directory to go ahead and display out the contents of test that out to ensure that it actually holds the contents from the prior call. Then we're going to go ahead and call ls, and we're going to pass it in our S driver Perl script. And we're going to send that out to test that out. And then we're going to cat that again to ensure that there's been a change in the contents. So this means, so let's think of a couple of things that has to happen here. This, when we first make this command here, there is no test.out file in our directory. This means we have to be able to create a file, right? Okay. And so then once we create that file, we've authored it, we've written content to it, then we're going to read that file using this cat application to display the text. Then when I go and do this third command here, which is the second redirect, this file already exists. So now what we have to do is overwrite it. And then we're going to redisplay the contents there. And then finally, we want to make sure that we can also delete it. We're going to remove that so it doesn't exist any longer. Okay, so let's see. Let's make sure. So we can see here in my evaluation. Oops. So we could say all the way up to 17. Yes, I have passed. So we've left off on these last couple traces, trace 18, trace 19, trace 20, all dealing with redirects. Yeah, perfect. Let me, while I'm here, go down here and open up my source code. Okay, so let's take a look at the difference between the output from the reference test 18 versus our tiny shell 18. We can see that we're going to get this expected behavior of sdrive.pl and then our tiny shell.c. This is when we call our reference tiny shell, this is going to be the output we're going to get. When we go to call, before we implement anything inside of our tiny shell, we're going to get, and so I've decided to start highlighting red and green. Green is where we're consistent with the reference shell from the get-go. The red illustrates instances where there's a difference between our tiny shell and our reference shell. So we can see, obviously, it doesn't understand, it can't parse the redirect symbols because we haven't tethered them. We haven't provided any logic for parsing those. So it's going to say it can't access this as if that's a file, because that's what it's looking for at this point. It thinks that's a file name. And then it's going to try to access test.out, but we haven't created test.out, right? We haven't added an implementation for authoring contents to a file. And so since we do that twice, we're going to get those errors again. And then finally, when we try to remove, there's no test.out to remove. So clearly, all the file management stuff has not been implemented. And so that's really what the discrepancies are. And so what we're going to have to do for this trace is implement the file handling operators for us to be able to complete this trace. So if we want to accomplish this, the first place we should kind of consider what to do is inside of our eval function, right? Our eval function is inside of our rebel, where we read, evaluate, process, and loop. The evaluation function is going to do the heavy lifting of deciding how to parse those command lines and then sending it to the appropriate helper functions. So there is a helper function that we'll need to invoke inside of our eval function so that when we do go ahead and decide that it's not a built-in function. So the first thing we do in the eval function, if you recall, and let's step through this, we parse the command line just so that everyone is reminded about what we're doing here. And again, what's highlighted yellow is going to be the new logic added into the pre-existing logic. So we're going to parse that command line to identify the command and its argument. We're going to determine if a command should run in the foreground or background. We are going to, if it does run as if it's not a built-in command, we're going to fork a new process so that we can execute it. At that stage, once we fork a new process, we need to check to see if we have to do redirects, because then we're going to have to parse that command line for potentially file in and file out names to redirect our standard in, standard out, or standard error. And then we can set the child process to a new process group to handle the signals appropriately. We can execute the command using the exec v, the exec vector system call in the child process. In the case of a foreground process, we have to wait for that command to complete. And for background processes, we add that job to the job list and return immediately. Well, we add the jobs to the job list regardless. But yeah, that's pretty much the logic. So this is going to be the new thing we're going to have to do, where we're going to refactor our eval to ensure that each child process potentially redirects the IO to the appropriate file. And of course, the motivation behind this change is this will allow us to do the redirects as we need to complete this trace. And we want to do that because we're trying to build a facsimile of a shell application, a shell. And so all shells have to handle these redirect operations. Okay, so the helper function we're going to depend on is going to be do redirect. It's going to scan our argument vector for any use of the greater than or less than symbols, which are the operators to indicate that we're going to go ahead and redirect to standard in or to standard out. Now, we're given this function. It's a helper function, but it's one that's only simply stubbed out. There's minimal implementation in there. This is not one of the functions that's completely just a return statement, but it does almost nothing. We'll take a look at it right now. If we look at do redirect, we can see there is our, we're getting our arguments array in. We have a loop control variable of I that we're going to go ahead and declare. We're going to create a for loop that's going to initialize at index 0 and go through all of the indexes. What's happening there of our yeah, that's not in the code. We're going to go ahead and initialize through all of our indexes. And in fact, why don't we look at the actual code now? So anyway, we'll go through all the indexes of our array. We're going to then check to see if that index is a less than symbol. If it is, then we're just going to go ahead and set it to null. Then we'll do an else if and see if it's a greater than symbol. And if it is, we're just going to set it to null. So really what we've been doing this entire time is just kind of removing those symbols. Or, I mean, we've never called this, so we're not doing anything with it. But all it does is it goes in and it kind of removes those. It just sets them to null. Yes. Yes. So no real implementation there yet. But what we need to do is go into our eval, and we're going to have to, once we've offloaded this work from our eval function to the do redirect, because that's where that logic's supposed to go, then we'll start fleshing out how to actually make that logic work. Sorry. Okay, so let's go into our eval function and actually set this up. But while we do that, okay.
No bullet points for including the append option.
I'm gonna bring this up actually in the tail end. No, there will definitely be bonus opportunities. And remind me to cover this again. There will be bonus opportunities, and I'm going to explain how that's going to work. So please remind me when we're done with the going through the traces and we talk about moving forward, how that's going to work. Okay, so let's jump here. Okay, so here I have my eval. And so inside of my eval function, what I want to do is after we fork, we're going to go ahead and we're going to call that do redirect. And we're going to pass it our argument vector. Let me just make sure that I'm in the same space here as where I expect to be. Perfect. Okay. And so here, then once we do that, let's go to our do redirect, because that's going to be the next thing. So we're calling that now, once we forked a process, to go ahead and try to parse so that we could set up the redirects for that. So here is the implementation that we just covered. And I'll be congruent if this is the default implementation. This is fine. I'm going to be more congruent with what I've been doing. They both result to the same, but for me, the logic is clear. Instead of nodding that, I like to actually just do an equality check to 0. It's more characters, but to me, it illustrates that there's a difference of 0 as opposed to nodding the results. Okay, let's save that. Okay, so let's talk about what we now have to do for that next part to work. So we now know do redirect is going to be this helper function. So right now what it does is it iterates through each element in our argument vector to find redirection symbols either greater than or less than, and then sets the redirection symbol and the file name in the argument vector to null to prevent them from being interpreted as command arguments, which is what's been causing some issues for us. But what we're going to want to do is in between that, for this particular trace, and actually, let's see what happens. Before we start talking about the logic, let's see what happens if we try to just compile our code and run it now. Okay, let's see. This is 2. Okay, perfect. So again, we at least didn't get one of the errors, right? Which was it couldn't open up a file that was the less than symbol. But clearly, we're still not dealing with any of the file stuff. Okay, so what's going to be the logic for how we're going to manage this? Let's look at the pseudocode first so that we can just kind of explain the step-by-step process. So after we iterate through each element in our argument vector looking for a greater than or less than symbol, if we see the output redirection, then what we're going to want to do is we're going to want to open the specified file with write-only access, creating the file if it doesn't exist and truncating if it does. So what we're going to do is we're going to use the system call open with these flags, and we'll talk about what these flags are in just a moment. Then we're going to also have to set file permissions for read and write access to the user, because remember, we have to write to it and we have to be able to read from it too when we do the cat. And then we're going to use a system call dupe2. So we're going to use a system call open, And to open a new file, or just to open a file, and it generates it if it doesn't exist already, that's going to be one of the, that's what these flags are going to help us with. And then we're going to be able to use dupe2, which is another system call, which is going to redirect the standard output, which we can express like this in our code. There's a label for it, a constant label, to the newly opened file, ensuring that our output command is written to the file. And then once we're done that, we are going to close using the file descriptor after duplicating to avoid any kind of resource leaks, and to make sure that we unlock ourselves from that file so that other applications can potentially access that file. If we don't close it from one application, the next application won't be able to lock it and be able to read from it.
Or you can make it quality control.
That's all, yeah. Okay, so once we have that, so let's go in through the key system functions. So usually after we go through the pseudocode, we kind of go and explain this a little bit more detailed. So we have O_WR only. We can think of that as standing for open for writing only. I tried to highlight or bold that which makes it make sense. It's a flag that's specifically used for that open system call to specify that a file is to be opened for writing. The O create stands for open create. That's a flag which is used with our open system call to indicate that if the specified file does not exist, it should then be created. And then O trunc stands for open truncate, which if the file already exists, it can successfully open for write operations. And so its length will be truncated to 0, effectively clearing the file's contents, allowing us to overwrite on the file. So we're just truncating at 0. Okay, so some other system calls and system functions that are worth knowing. Mode T is effectively going to be a structure, or it's going to be a type where it's used for our system calls like open for setting our file permissions. It's used when we create a new file or modify the permissions of an existing file. So when we create a file, we're going to use the mode T. When we read from a file, we won't need that. So you'll see there's two different set of parameters between this trace and the next that we'll be making use of for the open call. So now here for the mode, we're going to use the set inode read user and set inode for write user. So this is going to allow us to set the file permissions when we make this open system call so that we can give the necessary privileges to that file. So again, we need to issue read and write privileges. And so an inode is a data structure at the system level that maintains kind of all the permissions and information, the metadata associated with that file. The actual system call, so all of these are pretty much representative of particular attributes that we're using. The actual system calls we're going to be using is the open system call, which is used to open a file. And then we're going to pass those flag values so we can set the permissions and all the different attributes that we have to have for that file. Dupe2 is going to be a system call that's used for duplicating a file descriptor. It's essential for redirecting our standard input and output so that we can go ahead and implement these traces. We have a close function, which is going to allow us to close a file descriptor. And so this system call is going to release the resources and ensure the changes to the file are saved. And finally, since for this trace, we're dealing with redirecting the standard out, well, we can use this constant here that represents standard out file number, which represents the standard out file descriptor for our system. And usually that has a value of 1, but we use the alias, right, to ensure that our code is readable and whatever it is, it actually works for our software. And then if we just look at the API, we could see with open, we provided a path name as the first parameter. The flags for our file which effectively are represented as an integer value. And then the mode, which is going to give the privileges. And so typically with the mode, we're going to really use this third parameter on the instances where we use the flag to create a file. If we're not going to include the flag to create, we don't necessarily have to include a mode. Now, since we are going to create, we are going to include that on this instance. With a close function, we just have to provide it the file descriptor that we want to close. And it's going to return back a 0 on success or a -1 in case there was an error. Did I mention here? I didn't mention on open. I should have mentioned on open. What happens when we open a file is it does return back an integer value, and that integer value is the file descriptor, so that we can recall that file later on so we can close it. So we can track our file, this particular file, by its file descriptor. And again, a file descriptor is going to be a non-negative integer on a success or a -1 on a failure. Again, if I'm implementing any kind of error management, I'm looking at what those integer values are returned at, and then I'm resolving to do some kind of print statement to the user to allow them to know that there was some kind of error or fault in what they requested. And then dupe2 is going to take in a old file descriptor, which is an integer value, and a new file descriptor, which is an integer value. The first is the file descriptor that is to be copied, and the new file descriptor is going to be to which the old file descriptor is duplicated. So the concept of redirect is the software is sending all of the content to our standard out file, our standard out stream. And when we do a redirect, we want to take everything that's being copied into that and duplicate it into our file, so that we can get that behavior with this system call. And just so you know, the particular will have a couple of constants that represent our standard out file number, our standard in file number, and our standard error file number. Okay, so now let's look at the actual implementation after talking about the pseudocode, after reviewing some of the system calls and system fields that are available to us. The implementation is going to be as such. So in the instance that it's the greater than symbol, the redirect for output symbol, we're going to set our flags. Now, we looked at the function call on open. We know that the data type for our flags resolves to be an integer value. We stated that for the ability to potentially create a new file or truncate to a pre-existing file such that we have write-only privileges or with only write-only operations, we're going to use these particular values, and we're going to go ahead and do a OR operation on them, a bitwise OR operation on them. Okay, that's going to set, that combination is going to set the value that we need for our flag to send to open. That's the second parameter that we need for open. Then what we're going to have here is we're going to go ahead and set our file mode. So we said that our file, the privileges we would need would be the ability to read and write. So we're going to set the inode read user privilege, and we're going to set the inode write user privilege. And again, we're going to use a bitwise OR operation to be able to get those two. And then we're going to save that into our file mode, which is going to be that data type mode T. Okay, so this is my third parameter. So now when I go to call open, the file name should be inside of our command line argument. So at I is the instance in which we have a greater than symbol. So that means the thing immediately after the I is going to be my file path or the file name that we're redirecting our system.out contents into. So we're going to pass that as our argument, as our first argument. We're going to pass our O flags as our second argument, and then we're going to pass that file mode as our third argument. Then this should return to us our new file descriptor, which is an integer value. We need that because we passed the new file descriptor and the old file descriptor to the dupe2 function such that it will grab the contents from standard out and author it into our file. And then when we're done, we will then close our new file descriptor. And then after that, we still have to go into I, and after we've set all that up, we got to remove that operator. Okay, let me go and implement that. So inside of here, let's see here. So we're going to do our O flags, and we said our O flags is going to be the open for write only, and our open for create, the open for the, oh, there we go. Perfect. Okay, so that's going to be our flags. Then we're going to have to get our mode since we're creating a file. So we're going to call this file mode. And then what I'll do here is it's going to be set inode for read user and set inode for write user. Perfect. And then once we do that, we can then go ahead and call, let's do our new file descriptor. We can call our open function, and we can pass it our argv at I+1. We can pass it our O flags, and we can pass it our file mode. And then once we do this, we can go ahead and call to dupe2. So we will do dupe2, and we will pass it the parameters of our new file descriptor and our standard out file number. Perfect. And then finally, we're going to close that. Once we've set up the pipeline, we can then, new file descriptor. Excellent. Let's save that. Let's compile, make sure that we don't have any issues with our implementation. It seems that I've compiled fine. For curiosity, I'm just going to go ahead and test to see what happens if I do a make on test 18, and we can see, oh, this looks like it's correct. So if I do a diff between those, and the nice thing about this is we don't have to contend with process IDs triggering my diff. So let me widen this so that I can try to get this all on one line. Yeah, so clearly the tiny shell ref, tiny shell, no such file, test that out. Oh, it seems to be in contrast here. No such file to remove. Let's double check.
So if you're running both.
Yeah, yeah. Yeah, it looks good to me. And in fact, what we can do here is while we set up the for 19, we will check just to make sure we get those points. So we'll let this run in the background. It's going to take a few moments. But let's presume, based off of the output that we saw, just inspecting our tester against our tiny shell and a reference shell, that we've completed that satisfactory. Well, then what's the next thing we need to do? Clearly, with trace 19, it should be obvious that if the goal of trace 18 was to implement the redirect for output, here we're going to redirect for input. So if we look at the comment here, we can see test whether the shell can properly redirect input. Yep, that's exactly what we're going to do. And there's only one thing it does, right? It's going to take myRead.c and redirect that into the .myRead10. And so let's see what the output is going to look like, even initially. So we can see that when we call myRead using the tester, so if we make our test, the reference test 19, it's going to say, oh, it's going to read 10 bytes from standard input. And then from that file, it's going to read the character / and then character read asterisk, and then character read blank space, new line character, then character read blank space, then character read asterisk, then character read blank space, then character read M and Y and R. So we can see the behavior of myRead, which is an application in and of itself, right? We don't really care about how that's implemented, but we can see when we pass that argument 10, it's reading 10 bytes from that. Whereas here, we haven't implemented any redirects. So it's just going to read 0 bytes from standard input because it's not reading from a file, right? There's nothing in standard input. Okay, so these are going to be our discrepancies here. So obviously, we're going to have to go ahead and implement our do redirect so that we can also take the contents of a file and copy it over into our standard in. And then here we go. We can see we did indeed pass trace 18, right? That was a success. So let's think about what we have to do in redirect to do that. Well, fortunately, do redirect is checking for both input and output redirections. So we just have to add logic on the instance when it's an input redirection. So if it is an input redirection, which is the less than symbol, we're going to open the specified file with read-only access. So that means we're going to use that open system call that we saw just last trace, and we're going to have to use the flag O for open read-only, so ORD, O only. And then we're still going to want to use that dupe to system call to redirect the standard input, which we have the alias standard in underscore file number to the newly opened file. Again, we don't like magic numbers, right? So we always use readable constants to represent these very critical system file numbers. Then once we're done that, well, that's it. Then we can kind of close our new file descriptor after duplicating it to avoid resource leaks, and then we can go ahead and set the redirection symbols. So the new concepts that we're introducing, well, we've already seen open, truncate, open, create, open for writing only. So obviously there's an open for reading only, and that's what our ORD only is for. And then we saw the standard out file number, where clearly there's also a standard in file number. So then the actual implementation for this would be inside of the selection operation for the less than symbol, we're going to use as our flag open read only. And then we don't need a mode because we're not creating a file. So on our open system call, we're going to pass it in, presumably after that symbol is going to be the name of the file that we're going to try to open. So we're going to grab at index I+1 from our argument vector, that file name, and then we're going to pass it the flag, the open flag, so that we can do this for read only, and it's going to attempt to open that, and if it's successful, it's going to give us a non-negative file descriptor. We'll then take that non-negative file descriptor, we're going to pass that to our dupe2 along with our standard input file number, and then we're going to close that new file descriptor once we've gotten all that plumbing put together. Okay, let me implement this myself. So inside of here, we're going to go ahead and set our flags. Okay, so let's see here. Our O flags, and we're going to set that to be our open read only. And then what we're going to be able to do is call that open system call. So we're going to capture the new file descriptor from that. So we're going to pass it from our argument vector at I+1, the file name, and then we're also going to pass it our open flags. And then once we have that new file descriptor, we can go ahead and call dupe2 on that. Where we will pass it that new file descriptor, and then we'll also pass it the standard in file number. And then once we're done that, we're going to go and call close on our new file descriptor. And we will save that. Okay. And then, of course, what was already implemented was after we do all the plumbing, we go into argvi and we null that out. We remove it because we've handled that part of our command line. So let's see if we can't compile and make sure there's no errors with our implementation. For me, it compiled fine, so there was no syntax issues there. And now let's see here. We never actually did, we inspected the slide, but I'm going to do a make r test 19. Okay, so that's what the slide said. Let me expand this, and now let me do make test 19, and we can say, oh yeah, perfect. That looks exactly the same now. And in fact, we can verify this by going and just running our check on our T shell. And while we go ahead and work on that check, let's take a gander at what the last and final trace is. And what you're going to probably notice is that trace 20 is just going to do IO redirection with both input and output. So it's going to use one file to redirect into the myread application for 40 characters. And then it's going to output that to /dev/null. So If we implemented trace 18 and 19 correctly, we're done with trace 20. So let's see. What we should get, if it does work, what we'll see once we get there, is that our expected behavior would be to read 40 bytes from standard input. And so our observed behavior should show the same thing. Read 40 bytes from standard input. When we send something to null, it's just discarding it. Okay, so then this is a moment of truth. Have we completed the shell lab? Gotten trace 15. And trace 16. Up. Yes, we can see. We passed trace 17, sorry, we're doing these right here. We passed trace 18, trace 19, and by consequence of those two traces passing, we've also successfully passed trace 20. So we are done with the base of shell lab. All 20 traces are successfully implemented. You should now have all the tools and explanation and slides and video lectures to be able to successful, and hopefully explanation. So like I said, bonus, right? You were asking about bonus, and I was going to wrap in, how is that going to fit? The next thing I want to do then is talk about how we're going to do our final. So like I said, you're going to have the opportunity to work in teams to effectively create a presentation that goes into a deep explanation of how a shell works using this code as a basis. If you want to get bonus material, you can make this code better. You can add functionality to it that we did not add. You can add fault tolerance in it that we have not added. Identify weak points, implement it, and in your presentation to me, show me how you've improved this tiny shell to be better than the one that I've implemented here in class. Yeah, just as long as it doesn't fail any of the traces. So you have to still pass the 20 traces, and then we can drop into your tiny shell and you can show me how you've made it better in some kind of way and explain the logic behind it and show me how you've done that. Does that make sense? And so that's what we're going to do as our final. Is there any questions?
Is that, how do we, are we going to be scheduling that?
Yes. So at any time, once you're prepared, send a request to meet with me. We will meet through Zoom. I'll schedule, and I'm expecting it to be, however, I'll let you go for as long as you need to be able to do a presentation, but your presentation should be no shorter than about 15 minutes. But I'll give you as long as you need to be able to go deep into a great explanation of how the shell application works. And so I'll give until the final day of exams as your ability to get this done. And once you're ready, just send me an invite, like hit me up on Discord and schedule with me effectively we'll do a presentation through Zoom. So I'll let you share your screen, coordinate with whoever is in your group to go ahead and be the point person to be able to kind of show off your screen so that we can have an not just like a code overview, but like however you present the content, and then you could show me your additional implementations. Let me make sure that there's no questions inside here. No questions in chat. Yeah, excellent. Okay, so if there's no other questions, really, this was the final lecture I wanted to have. I think we still have one technical lecture left, but there's not going to be any new content in it. So what we'll probably do for our last lecture is just make sure that everyone is grouped up and making progress. So I will have a check-in to make sure that everyone's assignments are turned in, everyone's done, feels good at where they're at with the lab work, and that everyone is where they think they need to be for the presentations that we're going to do for Tiny Shell. So what we can think of our very last day of lecture as a group meetup day. And just so you know, December 17th is the last day of finals. So you cannot schedule any time after that. So be mindful of your time. There's plenty of time to do this. There's plenty of time to do this. So just be aware and coordinate with your team members. Okay, does anyone have any other questions? Yeah, so December 7th is the last day. Did I say 7th or 17th?
I don't know.
Yeah, I mean, this semester's ending really early. We're not getting any lectures in on December, really. So it's nice, but I think next semester also begins really early. I think we begin like January 6th or so.
Yeah. Yeah.
8th, yeah, it's pretty early. Okay, well, I will end our lecture here today after kind of alluding on how the final is going to be. I will post this last video lecture up as soon as Zoom is done processing it, and then you can all get to work. Excellent. I will see you all next Tuesday.
One of the cool things of this one was we saw all the different files.